Hello and welcome to episode 10 of Modulus Manufacturing's build of the AR4 robotic arm. We're now more than halfway through the robotic arm build with joint 3, joint 2 and joint 1 installed and all of the wiring done for those 3 joints. So in this video I'll be showing the installation of the wiring for joint 3 and the connection of the joint 2 and 3 wiring into the electronics box, including the stepper motor drivers at the bottom. But right now I'll show you the movement of the arm. So here it is in the kind of most rotated position of joint 1, and we can rotate the whole arm around with that braided sleeve going round at the bottom. This will make its way round like this all the way until it gets to the joint 1 limit switch, which we hear just there. So we can bring that back to the main position of the arm, which sits like so. And now you can see with joint 2 we can go down to the joint 2 rest position, and then off the joint 2 rest position all the way forward with the braided sleeve having a little bit of excess there so it can rotate easily. And then once this is brought up into that main position, joint 3 sits up the top here and gets rotated by the joint 3 motor, and we've got the joint 3 end stop and limit switch up the top here. So follow along. The video does go into quite a lot of depth as to the wiring and the setup of all of these electronics. And then we'll be doing joint 4 in the next episode. Using the Extreme Flex Cat5e cable provided with the AR4 kit, we measure a 1.2 meter length of the cable, which you can see me doing here, although I've only got a 40 centimeter ruler. So 3 lengths of that ruler, and then I've got my 1.2 meter long length of the Cat5e cable. Once this is done, we can cut this and then use the exact same process that we did in episode 8, extending only a sliver of the blade of the Stanley knife, and then carefully cutting through the outer shielding of the Extreme Flex Cat5e cable. Following it along the length of the cable, this is much easier done on a hard surface, and then we can strip the outer jacket away from the inner shielding of the Cat5e cable. If you've been following along with the build series, by this point you've probably recognised that this is the exact same process we undertook in episode 8 with the extension of the joint 2 encoder wires and limit switch wires. So in the same process, we use the variable depth ANSIG tool to rotate around the outer shielding and cut through that shielding without cutting the inner wires. This is a pretty delicate process and it can go wrong, so exercise some caution there. And then we use the side cutters to cut off any of the remaining strands, and we can pull off the outer shielding and wind back the green cord that just covers the wires. Cutting that off with the side cutters, we now have our 8 inner wires exposed at a length of 15 centimeters. To ensure that we don't further fray the wiring, I cut some heat shrink and fit it over the top of the 8 inner wires and onto the top of the shielding at this 15 centimeter end of the Cat5e cable. We'll shrink this with the lighter in a further step. Flipping the 1.2 meter long cable around to the other side, we now strip 25 centimeters of shielding from the inner 8 wires at this end of the cable. We followed the exact same process using the variable depth cutter, side cutters, and then stripping the green cord away before fitting the heat shrink over the end to hold all of the wires together and prevent this end from fraying. After visually inspecting all 8 inner wires at both ends of the cable to ensure that the variable depth cutter didn't cut through the insulation or impact the wires, I used a cigarette lighter to shrink the heat shrink and make a nice transition from the 8 inner wires to the shielded section of the Cat5e cable at both ends of the cable. To circle back and provide a little bit of context as to the Cat5e cable, the entire purpose of this cable is to provide a neat way of routing wires from the joint 1 base enclosure, where all of the electronics are, up the arm to the respective joints. At this point, we're taking the 25 centimeter end of this Cat5e cable and cutting the blue and brown wires back to a length of 5 centimeters, as these will be used to solder to the encoder wires from the joint 3 motor, whereas the longer green and orange wires will be used to go all the way up the arm to the joint 3 limit switch. Having cut the robotic arm end of the Cat5e wires to length, I strip back the insulation a little bit and then hold them in the mechanical third arm assembly and tin the ends of the wires in preparation for soldering them to the limit switch and the joint 3 encoder wires. Using the smaller 1/4 inch braided sleeve from the AR4 electrical kit bag, I measure and cut a length of 23 centimeters. This 23 centimeter length of the braided sleeve is fitted over the green and orange wires of the 25 centimeter length of the Cat5e cable. Getting these wires through the braided sleeve can be a little bit difficult, so I cut some heat shrink it with the lighter, and then feed it through the braided sleeve. Using the lighter on the ends of the braided sleeve also helps to hold the fibers together, making it easier to get through and a better cosmetic finish. Finally, I cut the heat shrink back off of the wires using the Stanley knife. Firstly, I cut off the solid green wire, which we're not going to use for the limit switch. You can see I've got both the limit switch and the wires held in the mechanical third arm soldering station, which makes it much easier. And here I'm tinning the lugs of the limit switch in preparation for it to be soldered to the wires coming from the Cat5e cable. Lining up the pre-tinned wires with the lugs, I first solder the striped orange wire to the lug closest to the switch itself. I then follow this with the striped green wire going to the comm lug on the outside of the switch, and then the solid orange wire going to the center lug. This can be a little bit fiddly, so sometimes using needle nose pliers to hold the wire in place as you solder it does make it a little bit easier. Finally, to neaten up the braided sleeve, we fit a small cable tie around the end of it and then cut off any excess with the side cutters. So as you can see here as a recap, we have the striped green going to the comm lug, the striped orange going to the normally closed, and the solid orange going to normally open. After ensuring all of the soldering joints are solid, I now apply a generous amount of liquid electrical tape over the top of each of the lugs, making sure to turn it around and cover all metallic surfaces so it's properly sealed against the elements. Once the liquid electrical tape is dried, I can grab this 3D printed joint 3 end stop that also houses the J3 limit switch. I can press fit that in there, making sure that the red side of the limit switch is inside of the enclosure with the writing right side up. Just like in episode 8, here I, for my own sanity, perform a continuity check with the multimeter. I hold one of the multimeter leads against the striped green wire, which is the comm lug, and the other against the striped orange and the solid orange wires going to the switch, and make sure that they perform as expected. So one should be normally open and one should be normally closed. After this, I can then perform the same continuity check on all of the encoder wires, holding a wire against a respective color at the bottom of the Cat5e cable and up at the other end where the encoder wires are, to ensure that the wires did not get cut when we were stripping the Cat5e cable. Okay, so after the pretty straightforward but tedious process of creating this extension cable for the joint 3 limit switch and joint 3 motor encoder wires, we can physically install it onto the AR4 robotic arm. Up the top of the arm here, we have the mounting holes for the joint 3 limit switch, which uses 2 M3 by 20 Phillip head pan screws. So tighten those up entirely into the arm, and we want to have the lever of the joint 3 limit switch pointing towards the front of the arm, so away from the joint 1 base enclosure when the arm is configured as you see on the screen. Tightening these up, they'll pull into the 3D print, being flush with the face of the 3D printed joint 3 end stop. At this point, the Cat5 extension cable is currently held onto the arm only by the 3 wires going up to the limit switch and that braided sleeve covering them. So to remove some cable tension and allow us to neatly route the cable down the robotic arm, we secure a cable tie around the joint 3 motor gearbox, holding the cable in place, as you'll see right here. So that cable tie is at the base of the joint 3 motor and then routes these cables over the end of the joint 3 motor close to the encoder wires.
Here, I'm trying to separate out the motor and encoder wires, and I only need the red, black, brown, and blue encoder wires. So you'll actually see I make a mistake here for anybody with a keen eye in terms of how I separate out the motor and encoder wires. And I proceed to separate out the encoder wires with the red, black, brown, and blue, but highly confused as I can't find the brown encoder wire. So having a look for it, I really thought it was the light coloured orange wire. The other motor encoder wires, including the yellow and green, can be cut off close to the motor. If you haven't already spotted my mistake with the brown motor encoder wire, keep watching and all will be revealed when I go to solder all of the wires together. In the meanwhile, I continue with the build process, cutting the motor encoder wires to a length of 4 centimeters away from the motor, and then I proceed to strip those wires afterwards in preparation for soldering. Using the mechanical third arm, I now tin the ends of the 4 encoder wires, being the red, black, brown, and blue, with me still assuming that the brown wire was the dark orange wire coming from the motor. With wires this small, tinning them is really an optional step prior to joining them to their respective wire from the Cat5 cable. However, I have found that it does make the process of soldering them together just that little bit easier. I now fit small sections of black heat shrink over the ends of the wires in preparation for the soldering. Using the alligator clips from the mechanical third arm assembly to hold the Cat5e and encoder wires in close proximity, I solder the solid blue encoder wire to the solid blue wire from the Cat5e cable. I then solder the red encoder wire to the solid brown wire from the Cat5e side, the black motor encoder wire to the striped brown wire from the Cat5e, and finally the brown wire, or what I thought was the brown wire, to the striped blue wire coming from the Cat5e cable. After this, I cover them up with the heat shrink and use a lighter to shrink the heat shrink to cover up the joint. Following the soldering, I grab the 3/4 inch braided sleeve, the larger of the 2 braided sleeves, and cut a length of 35 centimeters. I then use a lighter to singe each end of the braided sleeve before feeding the Cat5e cable through the braided sleeve all the way up to the joint 3 motor. Oh, I'm an idiot. It was at this point, after feeding the braided sleeve up, that I found the brown motor encoder wire nestled amongst the joint 3 motor wires. So the brown wire was indeed brown, whereas this light orange wire that was soldered to the striped blue Cat5 cable turned out to actually be one of the encoder wires that can be cut off from the motor. Luckily, this is a pretty easy area to get to, and there was no liquid electrical tape applied yet, so I was able to cut the heat shrink away from the top of that joint, cut the brown wire short, then strip the end of the brown wire, use the soldering iron to unsolder the light orange wire from the striped blue and white wire, and then solder that onto the end of the solid brown wire coming from the joint 3 motor. Having successfully fixed my first mistake of the project, I cut off the light orange wire that I thought was the brown one and feed the joint 3 motor wires through the 3/4 inch braided sleeve, make sure that they're bundled together and then feeding them all of the way through. After this, I can push the braided sleeve all the way up to cover up most of those wires and use a cable tie to hold the braided sleeve tight together right close to the joint 3 motor. As always, applying a copious amount of liquid electrical tape over the top of all of these motor encoder and motor wires into the end of the braided sleeve holds it all together and does a great job of sealing all of these joints. The final step of getting the joint 3 limit switch and motor wires back to the joint 1 base enclosure is to extend the joint 3 motor wires, and to do so I cut 4 lengths of 50 centimeter 20 American gauge wire, which is red, black, green and blue. So these 4 lengths of wire, you'll see I have all 4 wires here cut to a length of 50 centimeters, and I now go through and strip the ends of these ready to be tinned. With these thicker motor wires as opposed to the thinner encoder wires, I would recommend tinning these before you solder them to the extension wires. This just results in a much better joint overall. On the right hand side of the shot, you'll notice that I've got two of the same color. Those are the extension wires, the 50 centimeter long extension wires, and I'm putting both ends of it into the alligator clip of the third arm assembly and soldering both of them at the same time. Once I've soldered all of the extension wires, I now solder them to the motor wires themselves. So black to black, red to red, green to green, and blue to blue. Finally, to protect the connections from the elements, I put a small length of black heat shrink over each of the joints, shrink that with the lighter, and then put a larger piece of heat shrink over the top of all of that and shrink that down as well. Despite still including this in this video for transparency, this process here, in which I'm adding some blue heat shrink over the Cat5e and motor wires, is not in the AR4 build manual, and I actually wouldn't recommend it, as once it goes through the braided sleeve, it makes the cable a little bit more rigid and less easy to flex when installed on the robotic arm. Having shrunk the blue heat shrink, I then measure a length of 52 centimeters of the 3/4 inch braided sleeve. This can be quite hard to cut through, as you can see here, so using sharp side cutters or a Stanley knife certainly helps. I use a lighter to singe the ends of the braided sleeve, and then I shrink some yellow heat shrink on the ends of the motor wires and the Cat5e cables from joint 3, and mark these with 3 stripes so I know it's from joint 3. Before involving the larger 3/4 inch braided sleeve, I route the joint 3 cable harness through the center of the joint 2 turret. This goes through underneath the shaft and over the top of the joint 2 end stop. Once this is done, I take the 52 centimeter long 3/4 inch braided sleeve and fit both lengths of the Cat5e cable and the joint 2 and joint 3 motor wires through the braided sleeve. As you can see, this has already made a massive cosmetic difference to the appearance of the wiring, and I use a cable tie to tighten up the first braided sleeve and a second cable tie to attach it to the joint 2 end stop. Route all of the cabling into the joint 1 base enclosure. We remove the PG21 nut from the PG21 cable gland. After all of the wires have been fitted through that nut, we can then push them through the cable gland and they'll come out into the box, typically into the area underneath the main electronics tray, where all of the stepper motor drivers are. After this, we can feed all of the wires through and use some needle nose pliers to pull through any of the wires that are hard to get to, making sure that all of the wires are pulled perfectly through the PG21 gland. Make sure that we've got as much cable through as possible so that the gland itself can take the cable tension off. After this, we fit the outside sleeve itself into the PG21 gland to hold that in place, and then tighten up the PG21 cable gland nut, finally to hold all of the wires into the joint 1 base enclosure. With more than 20 wires added to the joint 1 electronics enclosure, it's looking like a bit of a dog's breakfast. So firstly, we sort this out and make sure that only the motor wires for joint 3 and joint 2 are underneath the electronics tray, whereas all other wires are folded back and brought up at the front of the joint 1 base enclosure so that they can be correctly routed on the top electronics tray. This then leaves us with only 8 motor wires at the bottom, the 4 joint 2 motor wires that didn't have any heat shrink over the top of them, and the other 4 joint 3 motor wires that have the yellow heat shrink with the 3 stripes over the top. Having separated the motor wires, we can now take out the terminal block for the joint 2 motor wires and fit in the 4 motor wires. So working from the back of the box, we have put it in with the blue, then red, then green, then black, with the black then ending up next to the red jumper lead that we'd previously put in on the stepper motor. So making sure that we tighten up the terminals with the small flathead screwdriver, making sure it's tight on the wires, and then we can press the joint 2 terminal back into the top of the stepper motor driver. We can then cut off the heat shrink and strip the ends of the joint 3 motor wires, before repeating that process. So making sure that from the back of the box, once again, it goes blue, red, green, and black, with the black then being next to the red jumper wire that you can see bridging each of the stepper motor drivers in the shot. Turning my attention to the electronics tray and the encoder and limit switch wires, I take the orange and brown wires for both joint 2 and joint 3, and so separating these out, making sure they're not twisted with any other wires, and make sure that they can run all the way to the terminal block in the back left corner, and then cut off any excess. Deviating from the AR4 build manual, which suggests soldering all of the wires together for the terminal block in the back left corner, I've opted to go for these small red-sized U-shaped lugs, which can be crimped. I actually cut off one side of the U, leaving a large surface area still on the left-hand side of each of the lugs, and then I can feed the wire into these and crimp it. To make them fit, I bend the U-shape up using a pair of needle nose pliers, which allows it to slide underneath the screw in the terminal block and have all of the wires neatly come out the top. In anticipation of crimping the wires for the 5 volt, 3.3 volt and ground terminals, I separate out the top of the brown and orange wire pairs and then strip them, ready to be crimped. With the wires stripped and the lugs prepared, we now remove the wires from the 3.3 volt terminal on the left-hand side of the terminal block. This already has the solid orange wire from the joint 1 limit switch and the striped orange wire from the opto drivers. We can then bundle these wires all together with the solid orange wires coming from joint 2 and joint 3, making sure that they're all held together with the exposed wire at the end before fitting the lug over the top and then crimping it all together. With all 4 wires for the 3.3 volt terminal, which includes the opto coupler jumper lead, along with the 3 limit switch wires, we can install this using the screw back into the left-hand side of the terminal block. Quickly moving on from the left-hand 3.3 volt terminal to the center ground terminal, we remove the yellow limit switch wire for joint 1 and the black encoder wire from joint 1, and combine them with the joint 2 and joint 3 orange and brown striped wires. To make it a little bit easier, I join all of these wires together in pairs before then combining all 3 pairs into one consolidated group of 6 wires. These are then fed into the lug and crimped. After wrestling all 6 wires into the lug, making sure that it was firmly crimped and all of the connections were solid, I then install that lug back into the center terminal of the terminal block. The final terminal of the terminal block is the 5 volt terminal located on the right handmost side. This only has one pre-existing wire, which was the red joint 1 encoder wire, and this gets combined with the 2 solid brown wires from joint 2 and 3. Crimping the lug, we can now fit this back into the terminal block and do up the screw. This completes the process of wiring the joint 1, 2 and 3 limit switches and the power for the encoders of joint 1, 2 and 3. We will have to revisit the terminal block in future, but for now we can actually use some cable ties to just neaten up the pre-existing wiring. Next up, we wire in the green wires from joint 2 and joint 3. Starting with joint 2, which I know is joint 2 because it's not in the yellow heat shrink marked number 3, I can separate out the 2 wires. The solid green wire actually isn't used, so this gets cut off as far down as possible. The striped green wire from joint 2, however, goes to the teensy breakout board to terminal 27. So we make sure that it's going to make the distance, leave a little bit of slack and cut it to length. After stripping the end of it, we can now use our small flathead screwdriver to open up the terminal and then fit in the end of the striped green wire before tightening it back up again. The next set of green wires are the easiest to find because they're the only ones left. We take them out of the joint 3 heat shrink that was used to label the wires, and then we can unwind them so that the 2 are separated, and then cut the solid green wire right back close to the PG21 gland. This time it's going to terminal 28, so once again make sure that the wire is going to be long enough, and then we can strip the wire open up terminal 28 on the front side of the Teensy breakout board and fit the wire into the terminal. Make sure that the wires are twisted round to go in straight with no stray wires pointing out, and then you can tighten it up. Finally, I undo terminal 16 and 17 in preparation for the joint 2 blue wires. These wires get brought over from the front left corner of the box to this back center position, and then I use needle nose pliers to fit the solid blue joint 2 wire into terminal 16, and repeat the same process with the striped blue wire, which goes into terminal 17 of the Teensy breakout board. Using needle nose pliers is almost a necessity here because it's so tight with the packaging to get the wires in, and you have to turn them 90 degrees from where they're coming from to get them into the terminal. So using needle nose pliers and the small electrical screwdriver certainly makes things a lot easier. Following the exact same process, I loosen off terminals 18 and 19 for the joint 3 blue wires. The solid blue wire from joint 3 goes into terminal 18, whereas the striped blue wire goes into terminal 19. You'll notice that it's a little bit too long with the solder on the end, so I cut that to length with the side cutters and then fit that into terminal 19. Once this is tightened up, I then neatly route those blue wires throughout the enclosure, making sure that there's still enough slack for them to easily move when the tray is rotated upward.
So there you have it, the completion of joints 1, 2, and 3 of the AR4 robotic arm. In this episode, we'd completed the wiring of the joint 3 limit switch, routed all of the wires throughout the robotic arm so far, into the back electronics box, and wired in the encoders, the motor power wires, and also the limit switches. Finally, we included the braided sleeve so that the arm can properly articulate without the wires getting in the way. In the next episode, we'll be going through joint 4, adding the joint 4 turret up the top of the arm here at the elbow to joint 3, and installing the joint 4 motor. So follow along, please like and subscribe if you're enjoying the videos so far, and I'll see you in the next episode.